My name is Engineer Holiday. I want to talk about repeat the class we did the last class in the that should be on Friday. We had a very big issue with the network, so we are going back to discuss it and in a simplified version. Now, this is the instruments used in measuring atmospheric pressure is what we call barometer. The instrument used to measure what atmospheric pressure is called barometer. And there are three types of barometer. We have that what we call a simple barometer. We have the simple barometer. We have what they call the floating barometer. And we have what they call the aneroid barometer. Now, these are the three types of barometer that we have. The three types of barometers are what? Simple barometer, the floating barometer, and the aneroid barometer. These are three good instruments we can use to measure atmospheric pressure. Now, the simplest among them all is what we call a simple barometer. And how is it constructed? Very easy to construct. Take your what? I have two diagrams here that I want to use to show it. Now, the first one is this place is called what? We have a tube that is what? Filled with air. And this one now, we fill it with what? With mercury. Fill the tube with what? The test tube or a long tube with mercury. Now, after filling with mercury, you place your thumb on it. Your thumb like this. You place your thumb on it. When you place your thumb on it, now, why do you place your thumb on it? To cover it, to seal the open end. Then invert it several times. When you invert it, what are you trying to do? In order to remove what? Air bubbles in the tube, in the tube. That means when they say invert, that means you cover it, you make it up, down, up, down, up, down. When you do that several times, you are trying to achieve, to make sure air is not trapped inside what? In the tube. Because if you don't do that, air can be trapped into the tube and it can affect the conclusion of this particular construction of the word of the barometer. Don't forget, if air is trapped, it will cause what we call a faulty barometer. A faulty barometer. And a faulty barometer is as a result of what? Air bubbles that have been trapped into the what? The long what? U-tube or the long test tube that you what? You fill your what? Now, when you invert it inside this, put it inside a what? A dish containing mercury. Now, when you put it in a dish containing mercury, this is what will happen. There will be a fall. That means you invert it, turn it, and dip it inside the what? The mercury dish. This is a mercury dish. As you do that, something happens. There will be a fall in the mercury column height, the height of what? The mercury column. Now, there will be a space that will be left here, and that space must be a vacuum. In other words, we call it the Torricelli vacuum. Torricellian vacuum. I cannot go there today. Now, this one now, the height of the mercury column is H, because it will now fall. Now, the fall of the mercury column depends on the what? Is supported by what? The atmospheric pressure. It is supported by what? The atmospheric what? Pressure. Now, if the mercury what that you place in it in this particular test tube is 760, for example, because it can either fall or rise it can either fall or rise. The mercury column height can either fall or rise. For instance, if I use 720 millimeter mercury to do this experiment, and the atmospheric pressure is 760 millimeter mercury, now the pressure will what? Will drop. That means the mercury height will fall in order for this pressure to be raised. Don't forget that the lesser you go, or let me say it might rise, because as you are rising, don't forget pressure is inverse to height. Now the height will fall when the pressure, maybe pressure is 770, is higher than the atmospheric. Atmospheric pressure is what? 760 millimeter mercury that is acting on the what? The surface, or the U-tube, or the test tube. Now if this particular, it will fall and it will stop, it become what? Stable at the point where the what? The mercury height is what? 760 millimeter, or what we call 0.76 meter mercury. Because at that point, the atmospheric pressure and the pressure of the mercury in the what? Mercury column in the tube will be balanced. So at what height? That is to say, this height measures the atmospheric pressure. This height measure what? Another name for atmospheric pressure is what we call the air pressure. Air pressure. Air pressure. Please take note of that. Now, the height of this one will not be balanced when the atmospheric pressure is being measured as balanced with the pressure of the mercury inside the tube. But if the mercury that you fill the U-tube, the long tube, with is 770, for instance, now because the atmospheric pressure is 760, that means the height of this column will have to what? To be raised up, so that this what? The pressure can drop. It will raise. That means the height of mercury column will rise, so that this particular one will now be dropped to what? 760. Until that height has what? Been raised, until this have attained 760, it will now be stable. At that point, in that is the what? The height at that moment is the measure of the atmospheric pressure. Now let's look at second case. In this case now, we not fill it with mercury. We just leave the test tube open like that to air. Then you invert it inside the what? Mercury dish. What you're going to notice is that the air pressure and the pressure, atmospheric pressure acting on the mercury is the same. That means the 760 millimeter mercury outside, in the tube inside, is also what? 760 millimeter mercury. That is to say that there will not be rise in the what? In the mercury column. In this case, the mercury in this dish will not go up. Why? Because the air pressure, which is also called atmospheric pressure, have the same pressure with the atmosphere. So in the case of filling with test tube or a long tube with mercury, it can either rise or fall based on the what, and it will stop at the what? Mercury what? Column height. The height of mercury column will be attained when the what? The atmospheric pressure is equal to the pressure of the mercury inside the what? The tube. And why is it that we always use mercury as a fluid? Please take on that. Mercury has a very high density. Water cannot be used as a barometer because it has what? A low density. And if you use water, the tube we are going to require to be about 10.4 or approximately 10 meters. Imagine using a long tube like that. To even see such a tube, it's what? It's not easily what? Come by. You cannot easily see them. So that's why we prefer to use density, because it has a higher density. A higher density than what? Than water. Number two is that also Mercury does not what wet glass, but barometer water wet glass. So in other words, when you are inverting it, you will notice that it is not all the water you fill this thing with that will later what, some of them will remain at the top of the what, at the top of the vacuum that will be created. Thereby, it will cause either an increase or decrease in pressure. So there will be what we call instability in measuring pressure. So water is not used at all. I'll stop there. Now let's go. The question is, if air bubbles now fill this place now, so we are able to know why water will not rise here. Water will not rise here because the air pressure, when you invert this tube and put it in the mercury dish, the air pressure here is the same pressure with the atmospheric pressure, so it will not rise. But this one can either rise or fall. If it rise or fall, it will be based on the atmospheric pressure of the liquid inside the water tube and the atmospheric pressure that is acting on it. That is true. When will it fall or when will it rise? It will rise when the pressure in the mercury you use is is 770, for example, higher than atmospheric pressure, and we need to drop this pressure. How do you drop the pressure? We make sure that the mercury column will rise, will go up, and when it go up, this one will now drop to 760, and at that point when it has dropped it to 760, it will now stable. So the height here, in other words, is a measure of the atmospheric pressure. What about if it is lower, maybe 720, for instance? If it's 720, it means that the pressure has to be raised. That means that this mercury column have to drop. So that when the mercury column drop, that means the pressure, we need to raise this pressure. So we need to drop the height. It will not fall. There will not be a fall in the mercury. So that the height of the mercury column will now be balanced, will now stop at the point where this thing will now be raised to 770, 760. That we now have a height where the mercury inside is producing the pressure or having the pressure equal to the atmospheric pressure. Another question that some people will ask: when will the mercury fall? The mercury will only fall so that the pressure can be raised. So mercury can fall so that the pressure can be raised. When it will really be so that it can be raised, when the mercury that you fill the tube with, that you invert on the mercury dish, is 720, lesser than the atmospheric pressure. So you need to fall so that the pressure can rise, because pressure is inversely to height. Then when we leave the pressure be or when we need drop or when we need rise, if this one is 780 or 790, the pressure is higher than atmospheric pressure. So there will be an imbalance in the mercury in the dish, in the U-tube, and the atmospheric pressure. So what will happen is that we need this pressure to fall to 760, then the height must be raised. So because when the height is raised, pressure fall. Don't forget, the pressure at sea level is 760 millimeter mercury, while below the sea level is higher than 760 millimeter mercury, while pressure at the mountain is lesser than 760 millimeter mercury. Take note of that. Now, when you invert that means you tilt rather. Let's tilt the tube. Tilt means to slant it. Let's slant it and ensure that air does not enters occupy above the mercury. Now we still notice that or air did not fill the or it's not found above the mercury column or mercury above there. We notice that H will still be the same. Why is H the same? Why did it not change? Because the pressure that is filling the liquid is already 760 millimeter mercury. It's balanced with the So tilting it, slanting the tube does not affect the pressure. So what we are concerned more is the liquid you fill with, we fill the what, the simple barometer with, is it higher or lower? That will decide. So if it is balanced, if it's 760, then you don't need to rise or fall again. You just remain like that. So even when this thing is balanced, if you teach it, it will see the height will see remain the same. Now, the pressure here, just say P1, let's take pressure. Let's say we fill the wall, let's have a faulty barometer where air is inside here. Once air is inside, what is found at the what? At the vacuum. How does it affect atmospheric pressure? Or how does it affect the pressure? It increases the pressure of the mercury in the tube. Please take note of that too. They can ask you, when air is found at the vacuum, what effect will it have on the barometer, on the simple barometer? It will tend to increase the pressure. Why? Because pressure will exert what? Gas will exert pressure. Don't forget that air is a gas. When air bubbles is a gas, then it will exert pressure on the what? On the mercury what? Itself. Thereby what? Helping to what? To reduce, to fall the what? The mercury column and increase pressure. That's what happens. So that's why we must ensure we avoid air here. So that, because only in 40 barometer you can have P1 V1 equal to what? In 40 barometer we can have P1 V1 equal to P2 V2. Now V1 is equal to area times height. A1 times height. Then V2 is equal to what? A2 times height. Because we are using the same tube, we will not change it to A1 is equal to what? A2. A1 equals to A2. So that one is noted. Then what is P1? P1 is what? Will be given in the question. Now, for example, instead of the manometer to measure what? 7 what? Instead of me to measure 75 centimeter, he now mistakenly measure, let's say 74.5. So this one now will now be removed from what? From this one to get our P1. I'm going to stop question on that. But note, this equation can be what? P1 H1 equal to P2 H2. And for correction of the what? Of the barometer. We are going to apply a question on that to see that. Now, let's even see a question on it so that we can know what? We can know what we are saying. Now, they said, as a result of air, let's take the question. As a result of air at the top of a barometer, as a result of air at the top of a barometer, the height of the mercury what? Column is 73.5 centimeter. When it should be 75 centimeter. That means as air bubbles introduce increase pressure now and lower the height. You see now what has happened? You see the effect of air bubbles in the barometer. Then the volume of the space what above the mercury is 8 centimeter cube. Now you say what? Calculate the correct what? Barometer or barometric heights. Calculate the what? The correct barometric height when the barometer reads what? 74.6 what? 0.0 centimeter above the what? 70 centimeter above, and the volume of space, let me write it above there. Volume of space above the mercury is 0.0 centimeter cube. Now we want to solve this question now. Now please take note of that. We want to solve question on simple barometer question so that we can see that question do come out from them, and it is not just explaining the theory, it has a calculation also. Now, having what explained that, they said as a result of air at the top, please, at the top of a barometer, the height of mercury column is 73.5 centimeter. Let's say what? Let's call that one P, because the height of that mercury column is equivalent to, it measures the pressure. Let's say P is equal to 73.5. Now, when its normal P should be what? When it should measure what? 75 centimeter. Let's be like that. Then the area or the volume is equal to what? The volume? 8 centimeter cube. V1. Now, then I said, look at when it should measure this, then the right measurement normally, the what? The normal pressure should be what? No, I'm using centimeter and I'm calling normal pressure because when somebody else can say, Mr. what about if I put mercury? Yes, you are correct. You can put it like that. Because it's mercury that is what? The height of is supposed to be 73.5 centimeter of mercury, because it's mercury that is filling that. So you can still leave it that way. Now, what about the second case now? Say what? Now they said the volume of the space above the is what it is. Above the mercury is 8 centimeter cube. Calculate the correct barometric height when the barometer reads what? Calculate what? The correct barometric height when the barometer reads 74. That is a fake reading then. 74 what? Centimeter of mercury. When the what? The correct one is P, which is unknown. Then what about the volume? This is P2. What about the volume 2? The volume 2 should be what? Equal to what? 6 centimeter cube. Because they told us what? And the volume of the space above the mercury is what? So 6.0 centimeter cube. So we'll play with it. Now what we are going to do now is to what? Use our formula P minus P1 times what? V1 equal to what? P minus P2 times V1. This formula we're going to use. So that we can get the, we need to, this is the what? The effect that comes as a result of air pressure. V1, then this is more or less like Boyle's law, but in this case now, we have the correct measurement P, then the 40 watt pressure P1. Now this will now be 75 minus, this is house I will need calculator, 73.5 times what? We have 8 is the what? V1. P is what? The second one, which we are not giving correct measurement. Don't forget, P is what? The correct what? Measurement, the correct what? Barometric height for that one. So that is, I'm going to have it as what? P minus what? What is the error of that 74 times what? What is the volume? 6.0. So what I'm going to have now is to what? multiply, open the bracket. First of all, 75.0 minus 73.5 is about 5. Remainder 4, 1, then 0.15. 0.15 times 8 equals to what? P. This times this will give us 6p minus this times we have what? 24 carry 2, 42. We have what? 444. So this one we was 75 minus 70 what? 3. We have carried 1 there. Subtract 1, there is 5. 10 minus 5 is 5. Remainder 4. 4 minus 3 is 1. Yes. So that's 1.5. Sorry, 1.5. So now what do we have now? We have this as our, this is 24. This is what? 444. You understand me? Now we collect like terms. Now this was multiplied by this will give us about 0 carry what? 4, 12. Is equals to what? 6p minus 444. So what I want to have now is what? Take this one here. I would have 12 plus 444 equal to 6p. Then I would have it as what? 4 what? 5, 6. 456 is equal to divide by 6. Then divide both sides by 6. So this one will give us what? P equal to what? 76 what? Centimeter of that what? Mercury. That's what I want to have as your final answer. So that is the what? The correct what? Measurements or correct barometric height of that one. You can write it like this. See the way I write it? 76 centimeter of mercury, because the height measures the pressure, the atmospheric pressure at that point. And the 40 what? This is actually possible for 40 barometer, not the one that is not 40. Because what bring about the error in that barometer is the air. You understand? In the air, and air can always, when it comes in at the top of the barometric or barometer, it increases the pressure. So please take note of that. Very, very important. Then number 2 is that how do we calculate what? The atmospheric pressure in a simple barometer. How do we calculate the atmospheric pressure in a simple barometer? How do we calculate the atmospheric pressure in a simple barometer? How do we calculate atmospheric pressure in a simple barometer? Now, what we are going to do is that what? Let's say to calculate the atmospheric pressure in a simple barometer. Now, what we want to do first is that since it's mercury we use in barometer, I told you the reason why. With the density of mercury now, is what? 13.6 millimeter or what? Times 10 by what? 3 kilogram per meter cube. Listen to that. Density of mercury is higher than density of water. Then what again? We have our G, acceleration to gravity. Let's say we take it as 10 what? Meter per second square. Then also to calculate that, we will need height at which what is support the atmospheric pressure, and that height is what? 0.76. We check, I explain it, meter, or what we call the 760 millimeter what? Height. This is the height that supports that what? Pressure. Because that's what you call, that's where they derive the word 760 millimeter mercury. So that is just that. I can clean this side now so that I clean this side. Now, I haven't done that now. Now, what is the pressure? The atmospheric pressure now, how do we calculate it? Normally. Now, atmospheric pressure equal to what? Rho GH. This is what? The pressure that what shows the relationship between a mountain and the what? And the air pressure. So that is, this formula can also be called the formula that shows the relationship between the air pressure and the what, and the atmosphere, the pressure at a particular hill or mountain. And that what we now do pressure ATN. So that's why when we say barometer is used to measure atmospheric pressure, how can we use, that's what we are doing now. You understand now? How do we use it to calculate atmospheric? We know that the barometer uses mercury, so that's the reason why we are using, because the problem is as students we don't know the reason why we are doing anything yet. So why do we use density of mercury? Because it's a what, barometric what, it's a mercury barometer. So mercury barometer, so it's a mercury that we use. Then the gravity is 10 from the G. Then the height at which what the simple barometer will always what attain to support the atmospheric pressure, to support the air pressure, is what, 0.7 meter. So it must attain, it must reach this height for what, the pressure in the atmosphere to support the mercury. So that's why we are using this height. Then when we now do that, 13.6 times 10 power 3 times, what is the pressure of the atmosphere, class? The pressure of the atmosphere is what? I mean, the gravity of the atmosphere is what? Let's say 10. Then what about the height? 0.76 meter. If you do that well and do your calculation well, you're supposed to have 1.013 times what, 10 raised to power what, 5 Newton per meter square, which is the same thing as what, 1.013 times 10 raised to power what, 5 Pascal. So if I ask what is the value of air pressure measured by the what, a simple barometer, the simple answer you will give to me is what, 10.013 times 10 to the power 5. That is simple answer, Pascal or Newton per meter square. So this is how we what, we use barometer to measure atmospheric pressure. And what is the pressure of the atmosphere? The pressure of the atmosphere is what, 1.013 times 10 raised to the power of 5. That is the what, the atmospheric pressure. Now we have also what, we have concluded everything that we needed to know concerning what, a simple barometer. Now what we want to talk about is what, where we are getting towards the end, is number 2, which you call the floating barometer. The floating barometer. Now the question is, what is a floating barometer? So it's an instrument used in laboratory. So it's a laboratory barometer. It's used in the laboratory to measure the atmospheric pressure accurately. So that means that the difference between this one and this one, number one, this one can measure atmospheric pressure accurately. Number two, because we hardly talk about the faulty part of this one. Then number two is that it is used in the laboratory. So it's a laboratory what, barometer. So it's very, very accurate. That's another thing about it. Very, very what? Very accurate. The floating barometer is very, but although it uses what? Mercury. Like what you are seeing, I see the diagram here. So that we can be fast. Now the vernier caliper is here. Then the scale is here. Then the screw here is to adjust the vernier caliper. Sometimes when you finish measurement, you need to take the vernier caliper to the what? This what? The point where you want to, the starting point is 0 mark again, so that we can take what? There will not be 0 error. Now there's a protecting brass tube, and inside the protecting brass tube we have the what? The mercury tube. This one, there should be mercury what tube here. Mercury what tube. Inside the mercury tube, we have what they call mercury and the fluid here inside there. Now this mercury now, how does it rise and fall? It rise when this ivory pointer coincide with what? The what? The what do you call it? The screw itself, the screw that is attached to the leather bag. And at the end of the day, when you notice that, what will happen is that the screw also helps to what, to adjust the mercury level. So there must this one now and the mercury itself, the pointer, the ivory pointer, will coincide with what, with the screw of the mercury what level, so that it will now what coincide to mark at what, 0. Now there is one question I what actually was brought out from that thing. They said when what, they say when the mercury surface just touches the ivory what, I mean this mercury surface now, when the what, this is barometer, the inside the mercury to have a what, a mercury there. Now then the mercury surface, as it touches the what, the ivory pointer, that means at that point, don't forget mercury is a conductive material. I hope you know. If you don't know now, mercury is conductive. Yes, so it's a very conductive material, and it's very nice. It's opaque. It's sorry, it does not wet glass. So now another thing again you must note here is that, so when the mercury touches the ivory pointer, now what we observe is that there will not be what, a 0 what, it will, I mean the fixed what, what do you call it, ivory pointer now will now have what, coincide with what, the 0 mark of the what, the 0 mark of the scale. And then when it coincide with the 0 mark of the scale, therefore we now measure the barometer there. So they will measure the barometer. So the mercury surface will decide alongside with the ivory pointer to know the kind of scale we are going to have. You understand? Although this one is fixed, it's a fixed ivory pointer, so it's fixed. So that's how it works. Although don't note that this one also uses what, mercury as what, as its liquid. So the barometric liquid of what, of simple barometer and barometer is mercury. But this last one does not use anything like what, mercury or any fluid at all. Oh, that is why it's very lovely. It is easy to carry about. Aneroid barometer is lovely. When I say lovely, it is easy to carry it about because of it does not use liquid at all. So you are not scared at all to move it around. Number 2 is what we call altimeter. So aneroid barometer is what we call altimeter. Altimeter is because it measures what, pressure at a particular what, height. At a particular, don't forget the pilot that move with what, at a particular altitude, and as they are moving in relative to what, pressure and height. So pressure and height is what they move with. Now in this case, now what we are saying is that the pressure with respect to the height, the altitude, is what we use what, aneroid barometer to measure. Look at this question. Somebody sent this question to me. Say what type of barometer uses what, does not use what, liquid or fluid before they can operate or measure atmospheric pressure? So the answer to that question is aneroid barometer. The next question somebody asked again that sent to me is that the atmospheric pressure, Mr. Holiday, decreases with ice. What did that statement mean? Because I think in our last class when I was explaining that, many people were not satisfied with some of the explanation. Now what I mean is that when the word pressure decreases with height. Now what we are saying that the higher the height, the lesser the pressure. It does not mean that pressure, as pressure decreases, height decreases. No. Try to understand that separately. Pressure decreases with height means that as height goes up, pressure goes down. That means as the aeroplane begins to rise, now the pressure becomes lower. Pressure becomes lower. Please take note of that. Very, very important. Pressure becomes lower. That is how what an aneroid barometer what operate. And I don't know if we can still have one more question to solve before we go. But before then, let's take this last part of questions before we go. Now, the height at which the atmospheric pressure ceases is what we call what 0 kilometer or 0 millimeter or zero anyhow. Either is 0 millimeter, centimeter. Zero is zero. And so somebody was asking me 0 centimeter and 0 millimeter. Is it the same thing? Yes, now because zero is zero. You cannot quantify zero. You understand me? So don't forget that the height at which what atmospheric pressure cease to exist is that when we say atmospheric pressure cease to exist, that means the point where what atmospheric pressure becomes what 0 millimeter mercury like this is what we call what pressure at which. So that means that when I tell you that an atmospheric pressure cease to exist at 80 kilometer, for example, 80 kilometer, what does that mean? It means that if I said at 80 kilometer, the aeroplane cease to what? To have an atmospheric pressure. It means that you get to a point where the aeroplane will attain, the atmospheric pressure is 0 millimeter mercury. Please take note of that word. Very, very important. So they can ask you at if the height of an aeroplane attain 90 kilometer, and at that point the atmospheric pressure ceases to exist. What does the pressure what is the value of the atmospheric pressure? That language already tell you that the atmospheric pressure is what equal to what 0 millimeter mercury. So is it possible to have an atmospheric pressure that operates at 0 millimeter mercury? Yes. So if somebody is telling you it's not possible to have 0 millimeter, it's a lie. You can have 0 millimeter mercury when at the point where the atmospheric pressure ceases to exist. Now, what about at the point where at the ground level, or what we call the sea level? What is the atmospheric pressure? At the sea level, let's say this is what? This is sea level. Now, this is below the sea level. At the sea level now, which we also call the ground level, the pressure here is 760 millimeter mercury. So the atmospheric pressure is 760 millimeter mercury. Let's say this is a mountain. We are using the diagram as a kind of sketch. At the mountain here, the pressure is less than 760 millimeter mercury. Please take of that. That is to say, as the height increases, what happens to pressure? Pressure decreases. That's what I was explaining. And that's why it is easy for us to use anaerobic barometer as an altimeter. Because you can as you get to a particular height, pressure drop. So therefore we can use the anaerobic barometer to measure the altitude at that particular point and relate it with the pressure. Now look at the word below the sea level. Below the sea level, that means when we say sea level now, the grammar is too much. The sea level is also known as ground level. Ground level, the surface of the earth is what we call the sea level. Below the sea level, pressure is higher than 760 millimeter mercury. Below the sea level, pressure is higher than 760 millimeter of mercury. So please take note of that. Very, very important. So now let's take the last question before I call it again. Let's take the last question before I call it again. So want to solve one question more, then we call it a day. This was the question 2, which is calculation question 2, this is question 3. But we have calculated the pressure, getting all this one. Question 3. Now I said calculate the height height attained by an aeroplane having a pressure having air pressure of 101 1.01 times 10^5 air pressure having what 1.01 times 10^5 Newton per meter square, taking the density of mercury to be equal to what 13.6 times 10^3 kilogram per meter cube. Please, we have a question here to solve, and that question says to calculate the height attained by an aeroplane having air pressure of 1.01 times 10^5 Newton per meter square or Pascal. Then take the density of the air, then giving us our gravity. They gave us gravity as what? Take G as 10 meters per second square. Now, what is another name for air pressure, class? Air pressure is also known as the barometric pressure. Barometric pressure. Air pressure is also known as barometric pressure. Air pressure is also known as what? Barometric pressure. That's another name for air pressure. Another name for air pressure is what we call what? Atmospheric pressure. Please take note of that. Note those three words I have just mentioned. The air pressure is called what? Barometric pressure, and also what? Atmospheric pressure. Why do we call it barometric pressure? Because it's barometer that we use to measure atmosphere or air pressure. The atmosphere can be measured with the barometer, so we call it barometric pressure. So now, in a barometer now, what does it use? If you use a liquid, and that liquid was what? Mercury. But the only case where it does not use liquid is the third case. So the three of them now, this one is more accurate, it's used in the lab, and it does not really give fault easily like that compared to this one. This one can be faulty if it's not properly done. But which of them is the simplest? This one, because it can be done even in the lab. It can be performed, it can be constructed easily. Now let's go. Now, what is the air pressure? I gave you air pressure, atmospheric pressure equal to what? Rho GH. So this is what the height at which the pressure is what? Our pressure supports this height. And this height is equal to what? The pressure divided by what? Gravity times density. So this is the formula we're going to use to solve that question. In our next class, we're going to see more questions, and we'll see some application, but we'll major on applications and more of questions in our next class, because time doesn't permit us to solve more questions today. So this is 1.01 times 10 to our 5 divided by what? What is our gravity? Don't forget, we are giving what? Pressure. Pressure is given as 1.01 times 10 to the power 5 Newton per meter square. We are given what? Density as 13.6 times 10 to the power 5 and 3 kilogram per meter cube. We are given what? Gravity as what? 10 meter per second square. So we are looking for H unknown. So that's what we are solving now. So we are going to have it as what? We are going to have it as 10 times, what is our density? 13.6 times 10 to the power 3. So final answer, what do you have? 0.7 what? 43 meter. Which is approximately what? 0.74 meter. So this is the what? Final answer. And I want to call it a day now for this night. We have tried. I know it's not up to 9, but we don't have time to solve more questions. So please ensure you subscribe to this what channel, and try to what also comment. We are not perfect. We are just what trying to deliver knowledge, and we know that we're also making research to make sure the class is very interesting. So make sure you have a nice day and have a nice what. Enjoy your time, and God bless you. My name is Edna Holiday. Please click the notification button so that whenever we send in our video, you can get them immediately. Thank you.